Today we're going to be taking a look at multipliers that are a little bit more difficult than we've been doing so far. So sometimes it's very obvious to see what that multiplier is. For example, if I have 4, 8, 16, our brain very easily says, oh, we're multiplying by 2. But of course, math isn't always that easy. So we want to see how this is going to be different when our multiplier is more difficult. For example, it might be multiplying by a fraction or a decimal or a negative number. So multipliers, of course, is the pattern of a geometric sequence. So that's either getting bigger and multiplying by the same number that's greater than 1, or it's getting smaller and multiplying by a number that's between 0 and 0.99. So here's a first example. We have -2, 3.2, -5.12, and 8.192. Now, I know that I need to find a number that will be the same every single time. Otherwise, it's not a geometric sequence and we can't make it an explicit or a recursive equation. So since I don't know in my brain, obviously, what do I multiply -2 by to get 3.2, I'm going to use the kind of formula that we've been talking about the whole time, which is the next number divided by the previous number. So we're going to go ahead and take the next number, 3.2, and divide it by -2 in our calculator. And it can be any two numbers that are next to each other. So we could have easily done 8.192 divided by -5.12. Obviously, it's going to be important to use your calculator for these. And so we know when we plug that in our calculator that 3.2, or 3 2/10, divided by -2 is equal to -1 6/10, or -1.6. So this is our multiplier. Now at this point, we want to make sure that that multiplier works for all of the terms. So we want to make sure and check this in our calculator every time, because if one of them is different, then it's no longer a geometric equation. So we know that -2 times -1.6 is +3.2. We know +3.2 times -1.6 is -5.12. Once again, you're doing this on your calculator. And we know -5.12 times -1.6 is +8.192. So once we verified that, then we're ready to go ahead and make our explicit equation. And we know for our explicit equation, the way that we've been using it in this class, not the only way, but we've been using x and y and the equation y equals a times b to the x, or y equals your 0 times your multiplier to the x power. So we're going to go ahead and work backwards and do the opposite operation of multiplying by -1.6, which of course is dividing by -1.6. Once again, you can see it's going to be important to have Desmos open online or on a calculator that you have in your hand. So -2 divided by -1.6 is 1.25, or 1 in 25 hundredths. So this right here is our 0. We're going to use this equation on all of our Desmos assignment today. We're going to use y and x. In this case, I just wanted to remind you that we can also use t of n and n in place of that, and this just specifically tells you that it's a sequence. So we know that a, which is our 0 in this case, is 1.25. We could also leave that as 5/4. And we know that our multiplier is -1.6. So when we plug the 0 in and our multiplier in, our answer is t of n is equal 1.25 times -1.6 to the nth power. Notice that the -1.6 is in parentheses, and that's because you can have two operations next to each other. You can't have times minus. So we have to separate that with parentheses. Okay, that of course is our explicit equation. So if I want to know what the 10th term is, I would plug 10 in for n. So I would do first in my calculator, parentheses -1.6 to the 10th power. I get that answer, and then I'd multiply that by 1.25 because of the order of operations. We need to make sure that we do our exponents before we multiply. We can also take the same information and we can go ahead and find the recursive equation. Remember, for recursive, it simply tells us two things. It tells us our first term and it tells us what's next. So that tells us our pattern. So a sub 1 in this case, our first term is -2. And then our pattern is times -1.6. So we're going to pop that in the bottom. And so this is our recursive equation. A sub 1 is equal to -2. and a sub n plus 1 is equal to a sub 1 times negative 1.6. And this is our recursive equation. And sometimes we're going to be asked for explicit, sometimes we're going to be asked for recursive on quizzes and tests. Now, our second thing for a multiplier that we see a lot, especially in word problems, is when we're given an increase or a decrease as a percentage, and we need to turn that into a multiplier. However, it's really nice. This is not something that is difficult. So here's our steps. Our first example, if it says in a word problem that we have an increase of 8%, for example, the ticket prices to go to Disneyland increased by 8% this year. So we would need to go ahead and convert this before we can put it into our explicit equation. So our multiplier, once again, is that pattern. It's the B of our explicit equation. So the very first thing you do is you take your 8%, you write it down as the number 8 in this case, and you're going to move your decimal places 2 to the left. So here's our 8 with our invisible decimal point, and we're going to move it 2 spots to the left with our fresh decimal point. Our second step is we're going to fill in our zeros. So as we go ahead and do this, we change our percent to a decimal. And so our new decimal is 0.08. Our second step is 2 options. If the problem is asking you for an increase, then you're going to take the number 1 and you're going to add the decimal you just found. If it asks you for a decrease, you're going to go 1 minus that decimal. And we know that's because in a sequence, if we're multiplying it by a number between 0 and 0.99, it's going to make it smaller as we multiply it. If it's a number bigger than 1, then it's going to make that number larger. So in this case, it's asked us for an increase. So we're going to go 1 plus 0.08. So our multiplier is 1.08 in this case, and that's what we would fill in for B in this word problem. Our second example is a decrease of 7%. So we're going to go through this same simple 2-step process. We're going to take our 7, we're going to move our decimal point 2 to the left, fill in our decimal point and our 0, and that becomes the decimal 0.07. This is a decrease, so we know the number is going to get smaller over time. So we're going to go 1 minus 0.07, and we know that 1 minus 0.07 is, here we go, 0.93. And we know that's accurate because it's getting smaller and it's a number between 0 and 0.99. Remember to put your 0 in front of your decimal. So don't just write 0.93, write 0 and 93 hundredths with that 0 in there. So once again, in the explicit equation, we would go ahead and use this as our multiplier. This is our pattern. We are multiplying in this case by 0.93 to get from one term to the next in our sequence. Let's go ahead and practice.